Oh, hello there, I didn't see you. Are you here to learn about equilibrium equations? Well, let's get started then. The first thing you need to know is the equilibrium constant. The Mach equation, as shown here, where the lowercase letters equal the molar quantity and the uppercase letters equal the products and the reactants of the equation. You plug it into this equation and product over reactant equals the KEQ. Let's do an example. Here we have hydrogen diatomic and iodide diatomic to react to create 2 moles of hydrogen iodide. So you plug the reactant hydrogen iodide up into the top, and it's 2 moles of that, so it's to the power of 2, over the products hydrogen diatomic and iodide diatomic, and that'll come out to be KEQ. By now, you all know that molarity equals moles over liters.
Equilibrium is affected by temperature. So as a general rule of thumb, constants are usually measured at 25 degrees Celsius.
And now we take this information and apply it to rice tables. Rice tables are a way of organizing what we've learned so far, where R is the reaction, I is the initial concentration, C is the change in concentration, and E is the equilibrium concentration, which is what we want to learn. Let's do, you guessed it, an example. The concentrations of an equilibrium mixture of O2, carbon monoxide, and carbon dioxide were 0.18 molar, 0.35 molar, and 0.029 molar respectively. Enough carbon monoxide was added to the flask containing the equilibrium mixture to momentarily raise its concentration to 0.6 molar. What will the concentration of each species in the flask once the equilibrium has been reestablished after the additional carbon monoxide was added? Using this information, you simply fill in the rice table. Now that we know the equilibrium concentration, simply plug that information into the equilibrium constant equation, solve for x, in this case using the quadratic formula, which doesn't always happen. Because of the nature of the quadratic formula, you get 2 answers for x. Now you can test both x's in the equilibrium concentrations, and if you get a negative concentration, you know that's not the right one. So in this case, the only possible answer is x equals 0.18. And now you too are an expert on equilibrium equations.